Hello students, in this video we are going to discuss the Biot-Savart law. Okay, so what the topic today, that is the Biot-Savart law. What the Biot-Savart law? Actually, we know that if we are taking any of the current carrying conductor, so according to the Oersted experiment, what the Oersted told, if we will take any current carrying conductor, then it will produce the magnetic field. Okay, so here we are going to find the magnetic field. How? So look here, just suppose we are taking, this is the one of the current carrying wire, and here the current flowing, that is I. And here we are taking one of the small element, that is dl, and this dl we will take in the direction of current, where the current is flowing. Now just suppose we need the magnetic field here, so at this location, just suppose this location is P, and here we need the magnetic field. So here, because of small element, we will find one of the very small magnetic field B. And the magnetic field is the vector quantity which is similar to electric field. Now, what the position vector of this? So we will take this R vector, this is the position vector. And one of the angle between the DL and the R, that is theta. That is theta here. And here we are going to find the magnetic field. And one more thing, Oersted experiment we will discuss in other lecture or other video. Here you should know only according to Oersted, if we have any current carrying wire, then surrounding it there will be the magnetic field, and we can find the magnetic field using the Biot-Savart law. Okay, and one more thing, look here, actually we know that the magnetic field is a vector quantity. So how we will find the direction of magnetic field? So to find the direction of magnetic field, we should understand the right hand thumb rule. So what the right hand thumb rule? Just suppose we are taking, this is the wire and the current is flowing from down to top like this. So we will use the right hand thumb rule, and using this we will find the magnetic field. So here if the current is flowing up, so we will take the right hand here and we will direct this thumb along the current like upside. So where the curl fingers, these fingers are acting like this, so this will be the magnetic field lines. Again current is moving up, so thumb will be along the direction of current, and the curl fingers will be like this. So what the curl fingers, this will be the magnetic field lines. And if we want the magnetic field intensity at any location, what we will do, we will draw one of the tangent, like here the thumb which is in direction of current and the curl fingers here. So if we need the magnetic field intensity here, we will draw one of the tangent. It means the magnetic field at this location will act from here to there, means this side. So using this we can find the magnetic field, direction of magnetic field. So look here, the current is flowing here. So because of Oersted, according to Oersted, the field will be in the surrounding. And how we will find the magnetic field here? Using the right hand thumb rule. So the current will, thumb of right hand will be along the current like this, and where the curl fingers are going inside, so there will be the magnetic field which is inside the board. And here we will draw like this. And one more thing, in physics, if we are using anything like dot means something coming outside, and if we are using cross means something or any vector which is directed into the board or the paper. Okay, so how we are getting this? Just suppose we are drawing one arrow. So if you will see from here, you will see there is the dot, and if you will see from back side, there will be the cross. It means dot means arrow is moving here, cross means arrow is moving this side. So you should remember, dot means coming outside, cross means going inside. So you should remember how we are finding the direction of magnetic field. For this we will use right hand thumb rule. So here now we are going to discuss what the Biot-Savart law. So according to Biot-Savart law, what the magnetic field here, small magnetic field, only magnitude we are discussing here. Okay, so this is proportional to current. More be the current, more be the magnetic field, because of current there is the magnetic field. And according to Biot-Savart law, uh, uh, this dV is also proportional to dl, and dV is also proportional to sine of theta, or the angle between dl and r, and dV inversely proportional to r square, inversely proportional to square of position. So what the magnetic field proportional to I, proportional to element, and the proportional to sine of angle between position and the element, and then dB is, or the magnetic field is inversely proportional to the square of position where we are finding the magnetic field. So this is the Biot-Savart law. According to Biot-Savart law, these points will be there. After that, if we are going to collect these all, so dB proportional to I dl sine theta divided by r square. And here, if we are going to remove this proportionality sign, we will get dB is equals to mu naught by 4 pi I dl sine theta by r square. This is the magnitude of magnetic field due to this element, due to this current element. Okay. So here we have this dB mu naught by 4 pi I dl sine theta by r square. This is the magnetic field. If we want to write this magnetic field in terms of vector, or vector form of Biot-Savart law, so here dB equals to mu naught by 4 pi I dl cross r divided by r cube, because if we will use this dl cross r, we will find dlr sine theta. We will find what? dlr sine theta. If we will find dlr sine theta, so r, 1 r here, 1 r here get cancelled. So again we will get same value. So this is the vector form of Biot-Savart law. This is the vector form of Biot-Savart law, and this is only magnitude there. Now we will discuss what the mu naught by 4 pi here. What the mu naught by 4 pi here? So mu naught by 4 pi is one of the constant. Mu naught by 4 pi is one of the constant, and its value is 10 raised to the power minus 7. And what the unit you should remember, that can be Tesla meter per ampere, or that can be Newton per ampere square, or there will be Weber per meter ampere. This is the unit. Tesla meter per ampere, Newton per ampere square, or Weber per ampere meter. These are the units of mu naught by 4 pi. Now here, what the mu naught? This is called permeability. This is called permeability. This is called permeability. And because of this naught, mu naught, this is the permeability of vacuum. So you should remember what the permeability. Permeability means this is the property of any medium, that can be here vacuum or any medium. Because of it will allow to pass the magnetic field through it. So what the permeability? Permeability is property of any medium. Because of this, it will allow to pass the magnetic field and nothing. So this is the permeability. So you should remember what the formula we are getting from the Biot-Savart law, that is mu naught by 4 pi I dl sine theta divided by r square. And what the mu naught by 4 pi, this is 10 raised to the power minus 7. And you should remember the unit, it will help you to solve the questions, that is Newton per ampere square, Weber per meter ampere, and the Tesla meter per ampere. These are the units. Now we are going to discuss one of the application of Biot-Savart law. One of the application of Biot-Savart law. So just suppose now we are taking one of the finite length current carrying conductor, okay, and we will find the magnetic field at any location due to this current carrying conductor. So here we are find one of the application we have, and in that application we are going to discuss what, that is the magnetic field due to a current carrying conductor of finite length. So we are going to discuss this. Now look here, just suppose we are taking one of the conductor having finite length, and this is the conductor AB, and just suppose we are taking one of the location here which is O. From here, just suppose we are taking this location, this is P, and here we are finding the magnetic field. Here we are finding the magnetic field, and this distance is given by D, and current is flowing from A to B, which is I, and here we are taking, just suppose this is origin or the reference. From here below Y distance here, one of the small element we are taking dy, which is directed here along the direction of current, and here from here this position vector we have, this is R vector having magnitude R, and this is the angle theta, Now here this angle we are taking phi, and if we are going to connect this angle is theta 1, and here we are taking this angle is theta 2, and here just suppose this location is Q we are writing. Now we will find the magnetic field due to current carrying conductor having finite length. Okay, now how to find? Here we will apply the Biot-Savart law. And what the Biot-Savart law? We have element dy and the angle between the r and the dy, which is theta, and here we need the magnetic field, and using the right hand thumb rule where the magnetic field will be directed. So thumb along the current and the curl fingers into the paper. It means here will be the magnetic field cross means what? Into the board. Now what the dB here? The only magnitude we are writing. Now dB equals to mu naught by 4 pi I dl means what? This dy sine this theta divided by this r square. Okay, now here we have what? Here just suppose we are writing this is phi, this is 90 degree, so tan phi equal to this is perpendicular y, and this is d base in this triangle which is O, Q and the P. Now what the tan phi here? Tan phi will be y by d. So what the y here? Y equal to d tan phi. This is y. Just suppose we are going to differentiate both sides, so we will get what? Here we will get dy, and why we are differentiating? Because we need the dy here. If we will differentiate here, so if we will get here dy, and here we will get, just suppose we are differentiating it with respect to any variable, like we are taking t. So differentiating this equation with respect to t, we will get what? dy by dt, and here d is constant, and what the differentiation of tan phi, which is sec square phi, so it will become sec square phi. Again differentiate phi with respect to t, here d phi by dt. So dt get cancelled. Because the dt get cancelled, that's why I told you all that we can differentiate the equation with respect to any variable, because it will be cancelled out. Now here what the dy we are getting? Dy is equals to d sec square phi into d phi. So we have this dy. Now we need the r. Again just suppose we are writing here sec phi. if we are writing here sec phi, so sec phi is what? Hypotenuse upon base. So in this triangle, what the hypotenuse, which is r, and what the base, that is the d. And what the r here? R we will get, this is the d sec phi. R equals to d sec phi. And one more thing, this is the right angle triangle, this is 90 degree, this is phi. Okay, this is phi. So what the theta will be here? Theta equals to 90 minus phi. Why? Because the sum of the all angles here 180, this is 90. So this plus this 90. So what the theta here? 90 minus phi. So theta will be 90 minus phi. Okay. And one more thing. Here we will find the small magnetic field. If we want the total magnetic field, what we will do? We will integrate finally. So look here. So here, what the magnetic field dB is equals to mu naught by 4 pi I. And what the dy we have? Dy is equal to d sec square phi d phi. D sec square phi d phi. So this is the dy, we have dy, and here this is sine theta. So dy we have, and what the sine theta? Sine theta means what? Theta means 90 minus phi. This is 90 minus phi divided by what the r here? R is d sec phi, so it will become d square sec square phi. Now what we did? We placed all the variables, all the values here in this equation. Now I am going to rub here. Now what to do? Now what to do here? dB equals to mu naught by 4 pi I, and here 1 d get cancelled, so by d, and here sec square phi get cancelled. Okay, so here it will become sin 90 minus phi, which is cos phi, and here d phi. Here this is the dB. Now we need the d. So to find the total magnetic field, what to do? We should integrate this from A to B, and here we will integrate this. Now look here. Just suppose this is the reference. This is the reference, and here we are taking this theta 1 clockwise, anti-clockwise, and theta 2 clockwise. So this theta 1 limit we will take here minus theta 1, and here plus theta 2, from minus theta 1 to plus theta 2. So this will be the limit. Now here we will get, I am writing here, so here the total magnetic field, which is B, and here mu naught by 4 pi I by d, and the cos phi, integration of cos phi is sin phi. Sin phi, and the limit minus theta 1 to theta 2. So B equal to mu naught by 4 pi I by d, and here what the limit? Sin theta 2 upper limit minus sin of minus theta 1. So here B equals to mu naught by 4 pi I by d, and here sin theta 2 and sin of minus theta, which is minus sin theta. So minus minus, it will become plus sin theta 1. So what the formula we are getting? That is of magnetic field of current carrying conductor having the finite length. So B equals to mu naught by 4 pi I by d, and this is to sin theta 1 plus sin theta 2. We have, this is the formula of magnetic field. You should remember this, okay? Now, finally what we are doing? So look here. So one of the other form of this formula is what? Just suppose we are taking, this is the wire, and the current is flowing, which is I. From here we are taking distance d, and here the magnetic field, we have this one theta 1 and this one theta 2. Now what the magnetic field here? B equals to mu naught by 4 pi I by d sin theta 1 plus sin theta 2. One of the other form we have, just suppose we are writing here, this is alpha 1, this is alpha 2, and here this is 90 degree, both are 90 90. Okay, this one 90 and this one 90. So B equal to mu naught by 4 pi I by d, mu naught by 4 pi I by d, and here sin theta 1 means what? Theta 1 means what? 90 minus alpha 1. So this is 90 minus alpha 1 plus sin theta 2 means 90 minus alpha 2. So B equals to mu naught by 4 pi I by d sin 90 minus alpha, which is cos alpha. So cos alpha 1 and here cos alpha 2. This is the another form. So look here in the question, if we are given this theta 1 theta 2, so magnetic field will be mu naught by 4 pi I by d sin theta 1 plus sin theta 2. If we are given alpha 1 and alpha 2 here, so mu naught by 4 pi I by d sin cos alpha 1 plus cos alpha 2. These are the formula. Okay. So in today's video what we learn, first you should know Oersted experiment. In detail Oersted experiment we will learn in other videos. Here you should know only if we have the current carrying conductor, then it will produce the magnetic field. Second thing you should remember, how to get the direction of magnetic field, we will use the right hand thumb rule. Right hand thumb rule means what? Along the current the thumb and along the curl fingers there will be the magnetic field lines. And at any location if you need the magnetic field, draw the tangent and nothing. After that we learn the Biot-Savart law. Biot-Savart law, actually Oersted told there will be the field due to current carrying conductor. But what amount of current field will be there? We will find using the Biot-Savart law. And Biot-Savart law formula was what? Mu naught by 4 pi I dl sin theta by r square. After that we learn, after that one thing, one of the application of the Biot-Savart law. If we want the magnetic field due to current carrying wire having the finite length, okay, then we found what the formula, this is B equal to mu naught by 4 pi I by d sin theta 1 plus sin theta 2. After that, if we, another formula or another form of this formula, so this is the mu naught by 4 pi I by d cos alpha 1 plus cos alpha 2. Okay. So we learn this all in this video. Okay, thank you.